right, so as people start to get into the webinar here, we're going to go ahead and get started. I'll do a little bit of an introduction for us today. So good morning to everybody. Thank you for attending. My name is Ashley Jones. I'm the technical support chemist here at IV, and I want to thank you guys for joining us today, as I said, and lending us your attention for a little while. I think this is going to be a really good discussion. We're going to go through increasing efficiency in your ICP analysis. We've got a couple of options for your standards and for your instruments, ways that you can make your own job a little bit easier on yourself. So before we get started, I just want to throw out there that if you have any questions at any time during our presentations today, you can enter them into the Q&A box within Zoom, and that way we can get to those at the end of the webinar today. If we're not able to get through everybody before our time is up, we will answer those questions in writing and include them in a PDF document when we send out our recording. So please don't be afraid to send your questions along, and don't think that we have missed you if we don't get to you over the call today. So first, I want to introduce Sergei here. He will be presenting first. Sergei is the co-founder and managing director of Texas Scientific Products, which is a supplier of high-quality consumables and innovative sample introduction systems for ICP atomic emission and mass spectrometers. Before he started at TSP, he worked as an applications lab manager for premier instrument manufacturers of both ICP-OES and mass spec, as well as microwave digestion equipment. An analytical chemist with an extensive scientific background, Sergei utilizes his 36 years of experience in atomic spectroscopy to help solve everyday real-world material analysis problems. At TSP, Dr. Leikin directs the new product and business development while keeping the focus on what he likes most, problem solving, which is a lot of what we're going to be talking about here today. Sergei received a master's degree in optical electronic systems and a PhD in analytical chemistry, and he has a lot to teach you guys today. So without further ado, I'm going to pass the floor off to Sergei.
All right. Well, thank you, Ashley. Yeah, I'm not sure about teaching, but I'll share what I know with the group, and hopefully we can learn something from you guys as well. So we're gonna set some time for question and answer session, as Ashley mentioned. So let's rock and roll. Let's dive into the world of ICP. So the topic of our discussion is when I look at the topic of what to present next from our first webinar that we did back in September about troubleshooting simple things. I was thinking about the operating parameters, and on the first glance it sounds basic, but when what we realize by working with you is modern instrumentation has this kind of hidden, and not everyone actually know what all these different parameters mean and how to use it in your daily operation to maximize the efficiency, or sometimes it's a question whether you can do the job or you cannot. So here is how some of the screenshots look like. And so the instrument is set up. You see this nice picture with gas flows, power, uptake rate, and everything. And that's the installation person leaves, and then you are up against all of those, and you need to do your job. So this screenshot taken from one of the brief notes from Agilent, and you see that in addition to what I call like a regular routine parameters, which is power, gas flows, you have all of this section about different uptake rates, injection time, injection volume, and things like that. So we're going to talk about this, how that all affects. When it comes to ICP-MS, there is even more involved, and this is the simplified version of the parameters. We're skipping the ion optic voltages and things like that. So there is more gases, there is more of the parameters to look at and how they affect. So typically, our routine parameters are those: plasma powers, gas flows, which is coolant in auxiliary, nebulizer or carrier. Then more of the instruments getting equipped with additional gas flow. And if it comes to ICP-MS, that's a makeup gas and dilution gas. So then the sample uptake rate. So that's the parameter that's a routine, but we're going to talk about how it affects it and what is the mystery behind that. and of course, the integration time. So here is the simple relation between the RF power that's here. So the power goes up, the intensity of your analytical line goes up as well. So does the background. And this is the area where you try to stay at by looking at your peaks and everything else. So the influence of the power or the power settings are important just from not just to get your maximum sensitivity signal to background ratio, stuff like that, but also when you run samples with high amount of totally dissolved solids or samples with high load, like volatile organics. So this is the power setting is critical. It is going to be between you can do the job or you cannot. So here is the anatomy of the gas flow, anatomy of the plasma. You can see there is a coolant gas flow, which is the one all you guys familiar with that cools the outer shield of the torch because the plasma is 10,000 Kelvin and quartz is take about 2,000, 2,500 in order for torch not to melt. So the coolant flow is running with pretty high flow at about from 10 to 18 liters per minute or up to 20. So then there is an intermediate or auxiliary flow. That flow is important, and that's something that you may need to change, and I'll show you later for some of the applications. And this is one of the key flows is your nebulizer that carries the aerosol, and it's called sample carrier. So the simple thing to look at how the nebulizer flow affects your plasma is represented by the bullet what we call bullet test, where you run yttrium bullet or sodium, or I'll show you later when you run organic matrix. So here is the position of the bullet, which is the transition between the excitation zone, which is the red zone right here, and the emission zone. It's a nice blue plume you see right here, and on top is the combination zone. Here's where the nebulizer flow is set up in the correct spot. Again, this is based on manufacturer recommendations, and here where it's hidden behind the second loop of the coil where the nebulizer flow is either too low or maybe nebulizer get clogged. But this is how you can simply look at it and see where you are as a starting point, and then you adjust it from there. So if you run organic matrix, this is how your plasma looks like. And so here, the nebulizer flow is set too low, and here, this is where about to at the right spot. So this is the example of the influence of the nebulizer flow on the sensitivity. It just took one parameter, influence of the nebulizer flow on the sensitivity without looking at the power and everything else. So this is the presentation of the work which we've done in collaboration in partnership with Inorganic Ventures. The work was done by Autumn Phillips, Inorganic Ventures R&D chemist, and we published it in the spectroscopy October issue of 2023. So the article called ICP OES as a viable alternative to ICP-MS for trace analysis, meeting the detection limit challenge. So there are two examples there of running the Big Four, what's called Big Four in cannabis, and that was picked up because it was a detection limit driven application, normally done by ICP-MS, but with the work that we've done, we were showing that it can be done with your emission machine. And the other example is analysis of high purity copper for certain elements that traditionally were able to be done by ICP-MS, like bismuth, tellurium, and lead, that very good by mass spec and have some not as good detection limits by ICP. So that was accomplished by using the high efficiency nebulizer we supplied in a number of other things. But coming back to what we're discussing, so you see when we started with the nebulizer flow influence, you see at 0.8, so the intensity is right here in the background, and you see the background corrected intensity. When we're reducing the nebulizer flow, you see that the signal goes up, so does the background, and the optimum spot is around 0.6 or 0.58, where the net intensity is up quite significantly by about 60%. So this is just to illustrate that what the influence of the nebulizer gas for the sensitivity, and that's what you can look at if you need to get maximum out of your instrument. So the other gas flow that I mentioned that's very important is the intermediate or the auxiliary gas flow. And when you're running samples with high amount of salts, or TDS, we call total dissolved solids, it's important to pay attention to it and adjust it if necessary. Because if you don't, so you might get the deposition on the tip of the injector from your sample, or if the plasma sits too low or too close to the injected tip, it can get corroded, and then you're up with the cost of replacing the torch and things like that. So what do? So you just increase the auxiliary flow, and by increasing it, so your plasma lifts up away from the injector, and that will help you to run either trouble-free or with much less maintenance and more efficiently. So here is the example what's happening in the when you're on organics. So here's this arrow shows, the nebula, the auxiliary flow is probably not high enough. And as a rule of thumb, if the different instruments have different settings, but it's about factor of 2 when you run aqueous versus organics. So here is what happened if your auxiliary flow is not set correctly, right? Or you may get such a nice looking injector with all the stuff deposited right on the tip of it. So that to show you the influence of the auxiliary flow. So let's move on, please, with some other stuff. So another flow that I mentioned that's becoming, well, it's been used in the industry for a long time, but it's coming standard now on some of the instrument, and that's the additional gas flow. So here is the example of how it could be set up on your instrument. So you get your spray chamber and the torch, and it's either the adapter between those two components is right here, or it can be this port for adding the or introducing the additional gas flow can be built right into your torch. So what it does, sometimes it also referred to as the sheath gas. It surrounds your the aerosol that travels from your nebulizer right here. So then this gas goes in and it packs it like it travels like an envelope. And when it comes to the torch, an injector torch, you have a barrier of the sheath gas or additional gas between your aerosol and the walls of the injector. What it does in practice, it reduces the deposition of the sample within the ejector, so you can allow longer, so you don't have less chance to have to recalibrate and things like that. So that's the function of this, the functionality. So then the thing is the question is how to set it up. The rule of thumb that you can use is when you run first without any additional gas, see that no gas is used, so you come up with some nebulizer flow, right? So then when you introduce in the gas, and this is just example, it could be 0.1, 0.2, it's not a big amount. So then this summary or the total of your additional gas and the nebula gas approximately equal to this number. So in this example, it's slightly below, it's 0.55, right, versus 0.65, but it probably could have been adjusted. It's just example from one of our customers that shares the conditions. But this is the approach. So you know what your nebulizer flow is with no additional gas, you introduce it, and then you balance these two flows to get, and you check with a bullet. So when it comes to mass spec, there is, like I mentioned, there is way more flows, and on the modern ICP-MSs. So here is the setup that was shared at the courtesy of University of Arizona, ALEC lab, that actually, you see the nebulizers, our Optimist Ion, gaining the popularity on the marketplace because it, believe it or not, but it doesn't clog with any of the samples. You can run through that. And so we had Mary Kay from University of Arizona just presented a poster at last winter conference that we can share with you it is available. We can share you at a later time, or you can contact to us. So when she ran for 9 months without even taking the nebulizer out of the system. But anyway, coming back to what we're discussing here, this is the nebulizer flow. This is the makeup gas. And those two gases work in concert or similar to what I just showed you for ICP emission, which is the combination of nebulizer and additional gas. Makeup gas sort of have similar functionality, but you set up your nebulizer. Your nebulizer maybe have a sweet spot at a certain flow, and which could be a little bit lower. Mass spec usually favors a bit of a higher flow because it corresponds to resident time, and then you need to get your low masses up, which favors the higher flow. So then you find the spot, and then you add makeup flow to add total what provides you the best performance. So here on the screenshot, that's from you see also the nebulizer gas, and then in this example the makeup gas not involved, but there is a dilution gas, and here it is. So there are two options for in this particular example for introducing the dilution gas into the system is right here when it's connected, and there is another port that's plugged on this picture. So what the dilution gas does, it's aerosol dilution module. If your sample have high TDS, and or your concentration is high, so instead of diluting it beforehand, you can dilute it with aerosol, and this is what the modern ICP-MSs are equipped with, and give you this power of doing that. So then we went through all of these parameters, and then it comes to the other three that we need to discuss is the sample uptake rate, integration time, and injection loop volume. This is something relatively well new that are the instruments equipped with or using this accessory. Now, how to determine the uptake rate? You see these conditions, and it's showing you, this is the screenshot from one of the software, showing you the pump speed and RPM. Now, what is RPM? RPMs are revolutions per minute. The question is, what relations the revolutions per minute is anything to do with running the sample, right? Running the analysis. So what we do need to know is the sample uptake rate in milliliters per minute. Then we can correspond it to any other things like injection loop volume and things like that. So it's actually relatively simple. It only depends on two parameters: is the size of your pump tubing, which is internal diameter, and speed of your pump, how fast the pump turns. So what you need to know is one thing, just a reference point. It doesn't matter what pump tubing size, it doesn't matter what the speed of your pump, as long as you know the combination of those and you know the rate, then you can calculate everything else if you change in the pump tubing and things like that. If you don't, or if you cannot get the answer from your application, especially, you can actually measure it yourself by collecting the sample at a certain speed and timing it. And you collect 10 mils, and if it takes you 10 minutes, that's 1 mil per minute. So it's pretty simple. So here is the formula. So your unknown rate, you take the reference rate that you know or you find out, and then you take the ratio of diameter and square them. So here is the example. So we take orange as a reference, right? And our uptake rate, so we know the diameter, right? That's known everywhere. There is a color code that corresponds to a certain diameter. So we know with 15 RPM, we get 1.1 mil per minute, right? So we got this information somewhere out of application support, or we measured. So then how to determine if we switch to different tubing diameter? So here it is. So you take this rate, 1.1, take the ratio of unknown to your reference, square it, and you get the result. So it's pretty straightforward, very basic math that you can do. Now, some of the software equipped with a calculator, but if they don't, so here is how you do it. Now we're coming to the integration time. I'll explain you why I brought this up. So the integration time defines how fast you are, how you're productive. On the other hand, it affects your detection limit. So you want to be more productive, you need to run with a less read or integration time. If you want to get your best detection limits, like in that example that I showed you before, you need longer integration time. So those things have to be balanced. And then you get here injection loop volume that see how it affects it. If you don't have the fast valve or express valve accessory or whatever, everything is straightforward. You have a better detection limit, you integrate longer. But you cannot do it just like that if you have the fast valve. And then we're coming back to the sample uptake rate. So here is the parameter that's added, it's injection loop volume. So how it all corresponds to each other. So to describe how the fast valve works, I just took a screenshot from our simple video of how to flush the nebulizer without using any expensive accessory, just a basic lab syringe that everyone has. So this is the load of your sample. Similar thing, you load your syringe. So your fast valve loads the sample into the injection loop. And then the next step is inject the injector in. See, here we're pressing the plunger and the sample comes out. You can see it's pretty big actually through the gas channel on our nebulizer. Or here on the second picture, even the bubbles sort of introduced. That's what actually the fast valve does to separate the segment. So again, load the sample and then inject it into the ICP through the nebulizer. Now on this step, when you're introducing it to the ICP, so you need to know the timing, what you have available. And here, what it comes down to. So I put this brief table. So if you figured out based on these other formulas, simple formula that I showed to you, so your uptake rate is 1 mil per minute, right? And then you have a loop volume that's 1 mil. That's kind of a standard setting that instrument can come with, but you have like a dozen at least of these different volumes coming from 0.5 to 5 or 6 milliliter volumes. So then at 1 mil per minute with total, with 1 mil available, you have obviously 60 seconds time available. So then if you run faster and get up to 1.5 mil per minute, so you may increase if you increase change the loop volume to 1.5 instead of 1, you still have these 60 seconds. Or if you're running faster but did not change the loop or staying with it, then we need to be aware that you only have about 40 seconds left. And this is the time that all time available that you have to take all your readings. There is a stabilization time and a bit of a delay and things like that. So if you take a reading for, let's say, 15 seconds or 10 seconds, you take 3 readings, that's already 30. Then in one mode, if you add another mode, that's already 60. So this is how you balance and find out whether you do need to change the loop volume or not. And it's really not a big deal. As long as you know what this does and how it affects it, you can do it. It's really, really not a big deal. Now, what I wanted to do at the end is to show you the what you can be done if you understand the effect of different operating parameters. And this is an example of running high voltage organic sample, gasoline, and that can be run straight. I repeat, straight without using any expensive cooling spray chamber accessories. I mean, if you do have it, great. But if you don't, if you budget limited, it can be done if you play with the parameters. And here is what was done. So the power, you increase your power to sustain the plasma. So then the key thing here is to reduce the sample load or the load of the plasma by limiting the amount of samples going to ICP. And that's done by 3 things. Using the smaller injector ID of your torch. Well, in this example, 1.2, it can be 0.8, depends on the instrument. Then you reducing the nebulizer flow. That when you use the nebulizer flow, remember I showed you the bullet, it also reduces the amount of sample that come into the plasma. And reducing the sample uptake rate by 2 things, by using the pump tubing with a small ID and slowing down your pump in those RPMs that I talked to you about. Of course, you need to have the nebulizer that is capable of working decently at a low sample uptake rate, but those nebulizers are available. Again, here, by playing with these parameters, by applying it, you can actually save you a lot of budgetary expense and get things accomplished. And this is just one example. Well, I appreciate your attention, and I encourage you to submit questions to Q&A box. And at this point, I'm passing this to Ashley. Thank you.
Thank you, Sergey. Let me get my screen shared here. All right. So in addition to some instrument controls and things that we can change, one of the things that we want to look at when we're talking about increasing efficiency is going to be what kind of standard you're using. And are you using single element standards to create calibration curves and things like that? Is that a way that you might be introducing uncertainty? You might be slowing yourself down and therefore costing yourself money. So we're going to go through some of the benefits of custom solutions. I think there are three main questions that new customers tend to ask themselves when they're looking into whether a custom solution might be right for them. The ones that I have heard and have answered the most often are, will they be easy to use? Will they be reliable? And will they be too expensive? I think the idea of a custom solution kind of brings about this image of, highly involved, very expensive, tailor-made solutions, but that's just not the case. We specialize in custom solutions here at Ivy, and I think we've got it down to a really good formula. So I want to take you through some of these points and maybe dispel some preconceived notions that might be in your mind about customs. So first and foremost, will the standard be easy to use? There are lots of factors to consider about whether a standard might be easier to use than what you're already using if you're not working with a multi-element solution, or maybe you're working with a stock multi that doesn't have quite as many, or maybe has too many analytes for your analysis. So one of the first things we talk about, and we talk about it quite a bit, is matrix matching. In a lot of cases, matrix matching is pretty easy. We can figure out what your acid is, and do something similar, try to keep a similar concentration. But in some cases, that's just not possible. And those may be cases where an internal standard is recommended, but that can also be pretty difficult. There are a lot of things to consider when picking an internal standard, and that's kind of a fine line to walk. So if you are creating your own standards, that might be more difficult to matrix match. If you need an internal standard, it might be hard to find one that necessarily has the same matrix and things like that. So if we create a custom multi-element solution for you, you have a little bit more control over the matrix, and you're not trying to keep track of the matrix of 25 different single element solutions. So we can definitely take that into consideration upfront and kind of save you some of the trouble and the worry about elemental compatibility and stability in that matrix as well. Elemental compatibility does take quite a bit of time to work through, especially if you're analyzing a large number of elements. We have 40 years worth of experience doing this. We've got a lot of trial and error behind us. And again, it'll just make your life a little bit easier to have someone else who is dedicated to sit and go through your elements and figure out where we're going to have problems. And then that way you can kind of avoid those precipitation issues, or even some of those instrument issues if you're not sure, which elements might require hydrofluoric acid stabilization, for example. So we can take all of that work off of you, and we can evaluate that on the front end. And then once you get your solutions, that's not something you should have to worry about. Our standards will be reliable. They will be stable because we've done all that work before we made it. It can also save you a lot of sample prep time. That's something that I hear a lot from our customers, is that if they're creating their own calibration solutions in particular, and they have a lot of elements to look at, it takes quite a bit of time. And when you're making a calibration curve, for example, you've got multiple points that you also have to create standards for. So either you're doing a serial dilution or you're doing these things individually. Both ways take quite a bit of time and have a really good potential for introducing error. Anytime we've got human hands on something, there's a good chance that it's not going to be quite where we want it to be. So when we have all of your elements in one solution, again, we've already made sure that they are going to be compatible, or that they can be recombined if need be at your instrument. That's a lot less work than having to do 20-something aliquots to create each point on your calibration curve. That's also going to allow us to take into consideration parts of your instrument or what solutions are going to work better, or we can counsel on concentrations and calibration curves and things like that. Like I mentioned before, hydrofluoric acid is very, very hard on a glass intro system. So we are aware of those kinds of things. We know up front, like I said, we have 40 years of experience figuring out what needs what and what kind of elements play well together. So we're able to take into consideration what kind of instrument you're using and what kind of method you're trying to run. And we can make sure that our solutions are going to be compatible with your instrument so that you're not finding out the hard way when your silicon and boron values are much higher than you expected them to be, that you're damaging your instrument. And then we can also take a look at starting materials. So if you have second source requirements, or you're just concerned about counter ions, if we've got, you know, a secondary, a counter ion in your typical starting material that you're not super aware of, or you're just trying to avoid and you're having difficulty, we do have alternative starting materials that we can go through. And again, we can make sure that whatever we're using is going to be compatible with your instrument. It's going to be compatible with your matrix. And we can kind of save you a lot of that guesswork on the front end. And again, we're going to test them on similar instruments. So we will have a test run. We'll make sure that it's easy for us to use, it's easy for you to use, and it will be safe for your instrument. Going to play nicely with me here. Next, how reliable is your standard going to be? So like I mentioned, anytime we've got human hands on something, there's a good chance that there's going to be added uncertainty. There's a possibility for human error and things like that. The more aliquots we have, the more solutions that you need to create, the greater that chance is. So when we're talking about reliability, our QC processes and our ISO certifications are kind of a stopgap to make sure that your standards are reliable before they leave the building. One thing that is really hard to sort of keep an eye on is starting material purity. There are a lot of market fluctuations, and as world events happen and certain ports and sources for starting materials change, we are keeping a really close eye on those kinds of things because we have standards for our certifications and for our products. We are customers of our own products as well. So we'll kind of keep a finger on the pulse of starting material purity, and that's something that you won't have to worry about on your end if you're buying a custom solution. We also have standards where some of our starting material is not as pure as we think it should be. So we will go through a process to purify it ourselves and to make sure that it meets our standards. So you can be sure at that point that there's not added impurity, or that you're worrying about finding vendors and keeping track of the kind of stock that they have available at that point. And then again, back to our elemental compatibility point, you're going to be sure that your standard is stable. So we design our standards to be stable for 5 years while they're in their sealed TCT bags. The 1 year expiration, once you remove it from the bag, is related to the transpiration, where we're losing water from the walls of the bottle. That's going to change the concentration of your analytes, but that's not necessarily to say that within a year your elements are going to be incompatible at that point. We design our solutions to be compatible for 5 years. So that you'll see notes or disclaimers when you get quotes for custom solutions, sometimes saying, we've split these elements apart because they wouldn't be compatible at this concentration for 5 years, but you could recombine them at your instrument, and they will be good to go and they'll be fine. We just want to make sure that we design things conservatively so that, like I said, they can sit on the shelf in that bag for 5 years and not have any compatibility or stability issues. We also have a pretty robust stability program. So if we have any questions about whether something might be stable as long as we would like it to be, we'll probably give you a temporarily shortened expiration period while we enter that solution into our stability program, and we test it continuously to be sure that once we offer you a stability or expiry guideline, that we're sure we have data, we have seen it, we know for sure that it's going to work. Traceability as well. Our NIST traceability is a really, really big thing for our customers. And again, it's just an added benefit if you were to buy a custom solution for a calibration solution or anything like that. You know that your calibration solution is traceable. It also has an assigned uncertainty, and you know that those values are certified. So there's less guesswork. Again, once you add something to your instrument, you're creating your calibration curve. Whatever you're adding, whatever you're using has been certified. You do have documentation for it. It is amazing for auditors to come in and have documentation and all the stuff available on our website at all times, anytime you need it, so you don't have to keep up with that paperwork. So it does make it a lot easier and gives you a little extra peace of mind to know that we have tested it, it is traceable, it is certified, and it is what we say it is. You don't have to find out the hard way yet again. And then, like I mentioned, our expiration, we have a 5-year expiration while it's still in our sealed TCT bag, and then 1 year from the date that it's removed from the bottle, whichever date comes first. And again, that's related to the transpiration. We have a lot of educational resources on our website about our transpiration study. If you would like more information, if you would like to see how we did it and how we determined that 5 years is appropriate. But it does definitely make things a lot easier, and it gives you a little bit of control over your lot of product if you're able to keep things for 5 years as opposed to having to use the entire lot within a year. And then again, will the standard be too costly? Is this just going to be too expensive to be worth it? A question that I've seen quite a bit is, if I get a quote from you, do I have to buy it? I'm not sure how other manufacturers handle that process, but no, quotes from us are not a binding document or anything like that. We do a lot of counseling and we'll go back and forth. And if you're not happy with the way that something is designed, or you would like to see something a little bit differently within the confines of, the laws of nature and chemistry, we can do a little bit of adjusting and make sure that you have exactly what you need before you buy anything. So we do have to consider the cost of numerous stock single solutions, for example, versus a single custom solution. In some cases, if you're analyzing few elements, it might be more cost efficient to buy those stock singles. But in a lot of cases, we have people analyzing, like I said, 20 to 30 elements at any given time. So that can really add up. And when you're having to keep track of each expiration and reorder points and things like that, it takes a lot of time. It's not just the cost of the product itself, it's a cost of the time that you put into buying it and keeping up with it and keeping track of all of your documentation and things like that. You also have to think of your consumables and your prep time. How much money are you spending to have someone create these calibration solutions if they're doing everything by hand? How much are you spending in pipetters and weigh boats and flasks and things like that to create a calibration solution that you could just get ready-made, certified, and NIST traceable in the mail? We also have switched to a volume pricing model for our custom solutions. So in the past, we had a multi-bottle discount where if you bought more than one bottle, you got a discount for numbers 2 through 3 million. For our volume pricing, you get a discount based on the amount of volume that you're buying. So you're getting a better deal than that multi-bottle pricing, because it didn't matter after the second bottle how much you purchased. It was the same price. Now, if you're purchasing more bottles, you get a greater discount per unit, because we're dividing the labor cost of all of your calibration solutions, all of your titrants, whatever you're ordering, by that entire lot. So each unit price is going to go down considerably with the volume pricing. And again, we have that 5-year TCT bag shelf life. So you can keep the same lot of product in their bags on the shelf. They're safe from contamination. They're safe from being tipped over, transpiration effects, and things like that. It really makes things a lot easier to not have to switch between lots of products and not have to revalidate, not have to, again, keep up with paperwork and things like that. So volume pricing really does give you a much better leg up if you're going to look at buying a larger lot and therefore having to do less work on the back end. So really, you're saving money up front and you're saving money on the back end having to keep reordering everything. So if you go through these considerations and you determine, yes, I want to analyze a lot of elements, or yes, I'm spending a lot of time doing these things and I only have one technician to do these and to test my samples and those kinds of things, custom solutions are always a great option. We're here to help counsel you through what kind of customs might be useful. You could get a single concentration, you could get a series of concentrations. We're here to help you make that decision. But once you've made a decision whether you want to go this route or not, you can then go to our website or send an email to us to request a quote. So like I said, we have almost 40 years of experience doing these kinds of solutions. So you've got a lot of know-how and a lot of trial and error behind you with our solutions that you won't have to go through the way that we did over the past several decades. Again, You'll have a member of our custom product development team there to counsel you through what kind of solution might be best for you and whether or not a custom solution is necessarily best for you. They could also recommend stocks if we have a multi-element stock or something of the sort that would work best for your method. We have a quick turnaround time, so custom standards will be ready to ship in 10 business days. Again, this is because your custom solutions are made and tested to order. They are made by people, tested by people once you place your order. So it does take 10 business days, but to save yourself all of the trouble of having to create them, 10 business days is pretty quick. And then again, our 5-year locked shelf life in those TCT bags really, really makes a difference. It's really helpful to keep your lot divided into smaller bottles so that, like I said, you can keep them away from contamination or being knocked over. If you're having an issue and you're not sure whether it's the solution or not, you can go pull one off the shelf and it's fresh and new, and you can see whether or not something has happened to that bottle that you're currently working with. So that's how we do it in-house. Like I said, we're a customer of our own products, so we keep our lots sequestered and we'll only use a bottle at a time just to reduce the chances that something has happened to it in the process of using it. Our custom process is pretty simple, which might not look that way on first glance here, but you'll go through either our website or emailing quotes@inorganicventures.com. You'll have your quote request reviewed by a 2-chemist process. We'll have someone design it and then someone to check over and verify that everything is correct and within our stability guidelines and things like that. The quote will be sent back to you for approval. Again, this is not a binding contract or anything of the sort, but you'll get a PDF with your composition and your matrix information, as well as your pricing and some options for bottle sizes and quantities. Again, if there's anything that you need changed or adjusted, we'll work with you to make sure that that is exactly perfect and what you're needing before you pull the trigger on placing an order. Once you're ready to place an order, the solution will be, like I said, manufactured and tested to order. It's going to go through our paperwork process. It's going to get all your certified values and all those things ready for the website. And then your bottle will be labeled, stuck in one of those TCT bags, and then shipped to your door. It is majorly helpful to have everything online. Personally, I feel it makes it so much easier keeping up with documentation. When we're going through SDSs and things like that for starting materials, when they're sent in a hard copy format, it is not only difficult for the environment, but it's so difficult to keep up with them and to make sure that they're matching lots and things like that with their paperwork. So to have that available on the website is definitely much more useful. You can download it. You can keep it in a file if you need to, but it's always there. It's always available for your auditors when they come through the door. We pull them every time. So yeah, you'll have everything you need within those 10 business days. Your paperwork will be available once the product is manufactured and sent to your door. So by the time you receive your lot, everything has already been done for you. You don't have to worry about the chemical considerations. You don't have to worry about your usage period or validation over and over with your instrument every time you change lots and things like that. It definitely will make your life a lot simpler. If you want more information about any of our products, about how, like I said, how we got here, how we obtained all of this experience, please check out our website or go through our new online learning platform, Ivy Ignite. This is where you're going to have some self-paced courses and videos, quizzes, community forums where you can chat with each other about things that you're experiencing and maybe a problem that someone else has seen in the past and knows how to fix. We also have podcasts available on Apple Podcasts. I think they're available a few other places as well, where we go through our ICP operations guide and our trace analysis guide. Those discussions are really helpful. We've got a lot of really heavy hitters in the league with their experience and advice on those documents that are, again, also available on our website. And that's through Ivy Ignite. You can also get PDUs and certificates. So those are things if you have new chemists in your lab or you would like to advance your own learning, definitely check out Ivy Ignite. It is a great resource. I like personally that it's self-paced. So if you're needing to step out and do something in the lab or there's something going on in the lab and you need to leave, we have pretty frequently, you have something else that you can focus on and you can continue your education. But definitely check out our educational resources on the website. We use them daily. It's where we have our interactive periodic table and our sample prep guides. They're really, really great resources. And a lot of it has been written by our founder, Dr. Paul Gaines. So just incredibly invaluable information there. So without further ado, stop sharing my screen here. And it looks like we've got some questions popping up. So our first one here from Robert Thomas. Looks like it's for you, Sergei. Says, you showed arsenic sensitivity by OES, but can you comment on the detection limit improvement of all the big four heavy metals compared to the maximum allowable limits in most U.S. states for inhalation cannabis products?
Yeah, Harold, thank you for the question. Yeah, the numbers are presented in the publication that actually you helped to edit, but the detection limit that we've got was about 50 to 100 times under the maximum allowable level, the strictest one in California. So we were able, just to give you an idea, we were able to put 1 ppb of arsenic and lead on the curve. Mercury and cadmium is not a problem at all. And with reducing the dilution factor, because there is a number of things that we did. First, we increased the efficiency by a factor of 2 with a more efficient nebulizer system. And then we reduced the dilution factor from what used in mass spec from 100.5 gram to 50 to 15. So by doing that, so we got the detection limits that are allowed to analyze cannabis under any strict regulations. So 1 ppb on the curve, and the real detection limits is probably, obviously below that if 1 ppb can go on the curve. So that's briefly to answer your question.
Thank you, Sergei. See, our next question up, there are two here that I'll kind of combine. I'm not exactly sure which concentrations are needed for the analytes in my custom. How does this process work to consult with your team? And how many elements typically fit into a single blend? Yeah, so if you're not sure what concentrations you're needing, we can definitely help. If there's a particular method that you're looking at, or what you're sort of expecting in your sample, we can work with you on what you're expecting to see, or we could give you some recommendations maybe for a stock to get started until you get a little bit more information, and you hone in on what you would like to see in that custom product. How many elements can typically fit into a single blend has a lot to do with volume and the concentration. So if you're looking for higher concentration, that's going to limit the amount of elements that we can add, just because we're going to reach a point where there's a volume issue, or there is a concentration issue. There are only 1 million parts per million. So at smaller concentrations, we can usually fit just about anything that you need. And we'll also have fewer compatibility considerations at lower concentrations. So that's definitely an option for like calibration curves and things like that. If your elements wouldn't play nicely at 1,000 ppm, because those are the stocks that you're looking at, they will probably be okay at working levels. So yeah, it's definitely worth asking. And there's some back and forth and some research that can happen if you're not sure what concentrations to go with at first.
Just to add to it, Ashley, real quick, the rule of thumb that we using and suggesting our customer is we ask for the concentration of your top calibration standards if you're already running, and then we try to design the custom standard with 10x or 10 times higher than this, so we create it like a concentrate, and then by serial dilution you can get to your calibration curve as a starting point.
Yes. All right, so we've got a few more here. I know we're running out of time. David asked, can NIST traceable AAS elemental standards be utilized for ICP? So if you're looking at like our AA line standards, yes, they can be used on ICP, but the thing to keep in mind is that their certifications are different. So for our custom grade line, the CG standards, which are also, that's how we name our stock products. For the CG standards, those will come with ISO 17034, 25, and 9001 certifications. Our AA standards are only 9001. So for us, those are intended to be more of a check standard internally. If you're doing any sort of audited process, you probably would not want to use those AA standards just because of the NIST traceability and the certifications. See here. Let's see. Would you please explain one more time the consumables cost savings? Yeah. So if you're having to create your own multi-element standards in-house, consumables, as far as my definitions are concerned, will be things that you use and then throw away. These tend to be plastic or in some cases glass, which can also be problematic depending on what you're working with. But there is a cost associated with those disposable items. And if you're not using disposables, there is also a cost with having to wash and maintain and calibrate those items. So if you're not creating those standards yourself and you're just ordering a bottle, it's dilute and shoot kind of situation, then you're going to be using a lot fewer of those kinds of things. It's just like your paper costs. If you're not printing out a lot of stuff, you're not going to have as much money to spend on paper. So it's kind of the same idea. The fewer disposable products we can use, probably the better, both for the environment and for the bottom line. Let's see here. I think we are getting close to time. See if I have another one. Sergei, this might be one that we want to expand on offline, but could Sergei expand on his discussion of the bullet test, also the optimization of gas flow versus RF and effect on background effects?
Yeah, I'm afraid the whole topic of the separate webinar, but important thing here to know. So the bullet test is a starting point. So this is the generic setting where it's your starting point or baseline. So you get this is the compromised position for number of elements. Example. So we had a customer that needed to do gain the detection. Well, in this case, detection limit for like for cannabis, big four, for arsenic and lead being the most critical one, or there are people who are doing phosphorus. In this case, you look at the excitation potential of these lines, and arsenic and phosphorus and like a chlorine, bromine, halogens available in some elements, they favor or they have a high excitation potential. So you need to increase your plasma and decrease your nebulizer flow. So your bullet may be not in the position that I showed you, but you will gain the sensitivity 100% with that. So this is how you kind of balance. You see what you need to do. You start with what you need to do and how to go about it. But generally, yeah, higher power, more excitation, more stable plasma, but higher background. But if you gain the signal, so you look at signal to background net signal, but also look the other parameter that I did not show that you have to look when you look at the detection limit test is with increased background, you have to make sure that the noise of the background is not going more than it should be. Otherwise, you're not gaining anything. So this is kind of with the time limited, how I can explain it.
All right. And then we have another for you, Sergei. The slide showing addition gas for OES with respect to the Y bullet. Will the bullet look the same? If no gas equals 0.65 and with gas sum equals 0.65, will it be the same in location? I haven't looked yet.
Yeah, Max, yeah, please take a look. It should be. That's a whole idea. Yeah, it should be. The combination of, like, if you reduce your, I mean, if you run a nebulizer at the same flow, and then you all of a sudden put the additional gas, so the bullet will go up. So that's why you're reducing the nebulizer flow if you add in something. This is how it all works.
Right. See, got one asking about the consumable procedure in India for CRMs, if a concerned person can guide for the product. I'm thinking this is a question about how CRMs would be ordered for customs for our customers in India. So we do service the globe, but it is difficult, as you can imagine, to get some chemical standards into different countries. Customs procedures are different, things like that. So we are very lucky to have partners all over the globe to help us do that more efficiently and to help us absorb some of that cost off of our customers for sending things all over the globe. So if you are a customer in India and you would like to request a custom solution, you can either go through our partner at Finar, or you could contact us directly and we will send your quote through our contacts at Finar. It's the same procedure. You'll let either us or your representative know what you're looking for. We will design it. We will ask questions and we'll have that same conversation we would have otherwise. And then when it's ready, we will send the quote through our contacts, and then they will get with you to handle sale and distribution of those products. All right. It looks like we have time maybe for a couple more questions quickly. So again, I'm going to combine a couple real quick. So if I get a particular custom formula in the US, what is the easiest way to ensure that they can be ordered by sister labs in other countries? Can they order the same part number? Yes. So that's one of the great things about our custom catalog. We have almost 70,000 unique solutions in our database right now. Those part numbers are transferable. So if you order something once, or if you order something in one location and you work at another location in 10 years, that part number still exists. It's still in our database unless we've discovered that there's something chemically wrong and we need to adjust the solution, but we can still find it no matter what. So yes, whatever part number you order, your sister companies can order it. If you move labs, you can still order it. Those part numbers are not going to go anywhere. And then if you have a multi-element standard, could there be interferences from elements in the standard affecting other elements in the standard? That's one of those things that I was kind of mentioning before. We'll do all of that work on our end. We'll make sure that they won't interfere. They won't have any major issues that would disrupt your analysis, so that's not something that you should have to worry about when you get the product and you're ready to use it. But again, if you're looking at creating your own solutions, or you just want to have a little bit more of a proactive approach to designing your customs, definitely check out our interactive periodic table. Each element has suspected or known interferences listed in the box that comes up. So those are things that you can sort of take a look at and take into account while you're selecting elements that you would like to analyze. But otherwise, we will do that kind of consideration on the front end. All right. Is the webinar recorded? Yes, it is. And I believe the link will be sent out after we conclude, along with that PDF of any questions that we weren't able to get with today. All right. So I think that is about us for today. If there are any questions that we have not gotten to, or that either Sergei or I particularly would like to expand on, like I said, we will type those out and we'll include them in a PDF document when we send the recording out. But thank you guys again for your time and attention today. It was really good to see Sergei and have an opportunity to collaborate on these kinds of things. So
well, thank you for inviting me over. Thank you.
Of course. Yeah. If you have any questions, or there's anything that you would like to talk to either of us about, related or not to this webinar, please feel free to reach out to us, and we will always be happy to help. Thank you guys and have a great day.